completely figured out my position on that yet.
Well, those videos kind of guide you toward, well.
Of course.
I mean, it's not like they try to be objective.
That's fine. I mean, they just kind of better when people have opinions. They can make their best argument. Okay, so I'm going to assume that you all want to go over the practice questions. So let's do that. My assumption is mistaken. Does anybody need, this is from the first day's handout. If you need an extra one, we have a bunch up there. File cabinets, so feel free to grab that. So you got the thick one? Yeah, you got it. So I'm going to use the root test to figure out the interval of convergence. Your book prefers the ratio test. I'll give you full credit for either one to use it correctly. So the nth root of an nth power, so it's going to cancel out. The nth root of n is just 1 times 3. And we want this to be less than 1. So remember, the absolute value is less than 3. That means the actual thing inside the absolute value is negative 3 and 3. So what I got is negative 2/3 here, 4/3 there. What's the center, by the way? So what's the x value that's going to make this whole thing 0? Or just the average of negative 2/3 and 4/3? So what we know is the ratio test with x values plugged in this range gives us convergence. X values plugged in this range gives us divergence. And the ratio test does not apply at negative 2/3 in so we're going to plug in x equals 4/3. Let's see. If I did this right, 3 times 4/3 is 4. Minus 1 is 3. So this is 3 to the n over n times 3 to the n, which is just 1 over n. And that diverges. The last test, we talked a lot about that. And so the easiest way to see it is the harmonic series. It's a p series. If you go back to the integral test, you can prove it diverges. And for x equals negative 2/3, get this. So negative 2 minus 1, this is negative 3 to the n times n times 3 to the n. Make it absolutely clear. I'll split it up into two factors, the alternator and the 3 to the n. And so now this is negative 1 to the n over n. Converge or diverge? Converges. So that's an alternating, by the alternating series test, that converges. So we got, I'm doing this in green, I guess, is negative 2/3 gave us divergence, and 4/3 gave us convergence. So the interval of convergence, the values of x that you're allowed to plug in there, in the interval notation, looks like this. And while we're at it, just because I didn't ask it on the practice test doesn't mean we'll show up on the real test. You should also understand the idea of a center and a radius. What's the center? And then the radius is, how far is it from the center to the edge? I'm going through these assuming you've looked at them already, so I'm just going to skim through and think out loud. If you want me to stop or you have questions, be sure to stop. If I plug in the first n value here, if I plug in n equals 1, is that going to be a constant term or a term with variable? So if I plug in equals 1, is there an x, or am I raising it to the 0 power to get it a constant? It's still an x, and the derivative of x doesn't turn into 0. There is what the derivative looks like. And if I know the center of a power series, and then I go to, you got a good day. Its derivative, does the center change? Does the radius change? Does the interval change? Maybe. So for the derivative, it's going to look like this. Okay, so the derivative puts an n in front of each piece. And with the n there, does that make it bigger or smaller? So if I have whatever term I have here, so let's say this is n equals 2, and then I change it, my n equals 2 for the derivative is this piece times 2. And the n equals 3 term looks like this. And for the derivative, the n equals 3 term looks like 3 times this. So I take the derivative. Are the terms getting bigger, smaller, or we can't tell? They're getting bigger. So if it already diverged, again, you made it get better, bigger. Is there any way that could converge? So we can check it, but we already know from our work on the previous problem that this is still going to diverge. And so the only real question is what happens at the other end. It's possible that making it bigger turn the convergent sequence into the divergent sequence. If you don't like that way of thinking about it, you can do it by hand. Four-thirds converge last one? Is that right? Yeah. Okay. So this is 3 to the n minus 1 over 3 to the n. And this is just 1/3. bottom, the 3 to the n minus 1 times 3 is 1/3. So if I take 1/3 plus 1/3 plus 1/3, and keep doing that infinitely many times, converge or diverge? What test? Good test for divergence. These don't go to 0. The test for divergence tells us that it diverges. So there is the interval of convergence for f prime.